Chlorine is the 17th element in the periodic table, with the atomic number 17. It belongs to group 17, known as the halogens, which includes fluorine, bromine, iodine, and astatine. Chlorine is a nonmetal and is highly reactive, especially in its elemental form. It exists as a yellow-green gas under standard conditions and has a strong, distinctive odor often associated with swimming pools and bleach. Though toxic in high concentrations, chlorine plays a vital role in both industrial applications and biological systems. It was first isolated in 1774 by Swedish chemist Carl Wilhelm Scheele, though it wasn't recognized as an element until 1808, when Sir Humphrey Davy confirmed its elemental nature and named it chlorine, derived from the Greek word chloros, meaning greenish-yellow. As a halogen, chlorine has 7 electrons in its outer shell, making it 1 electron short of a full octet. This incomplete valence shell drives chlorine's strong tendency to gain an electron in chemical reactions, often forming chloride ions, CLA. This high reactivity means that elemental chlorine does not occur freely in nature. Instead, it is commonly found in compound form, most notably as sodium chloride, an ACl, or common table salt, which is abundant in seawater and mineral deposits. Chlorine's reactivity is central to its broad range of applications. One of its most important uses is in water treatment. Chlorine is widely employed as a disinfectant in municipal water supplies, swimming pools, and wastewater facilities. When added to water, chlorine forms hypochlorous acid, a potent antimicrobial agent that kills bacteria, viruses, and other pathogens. This application has had an enormous public health impact, drastically reducing waterborne diseases in developed and developing regions alike. In addition to its disinfectant properties, chlorine is essential to modern chemical manufacturing. It serves as a building block or reagent in the production of a vast array of products, including plastics, solvents, pharmaceuticals, pesticides, and cleaning agents. One of the most notable chlorine-derived products is polyvinyl chloride, PVC, a widely used plastic found in everything from plumbing pipes and flooring to medical devices and packaging materials. The production of PVC relies on vinyl chloride monomer, which is synthesized using chlorine. Chlorine is also used in the bleaching process for paper and textiles. In these applications, chlorine or chlorine dioxide acts to remove lignin from wood pulp or to whiten fabrics, resulting in brighter, cleaner products. Although these processes have come under environmental scrutiny due to byproducts like dioxins, advances in technology and regulation have led to cleaner, more sustainable methods, such as elemental chlorine-free, ECF, and totally chlorine-free, TCF, bleaching techniques. In organic chemistry, chlorine is commonly used to modify hydrocarbons, resulting in chlorinated solvents like chloroform and carbon tetrachloride, which were historically used in dry cleaning and refrigeration. However, due to their toxicity and environmental persistence, many of these compounds have been phased out or replaced by safer alternatives. Nonetheless, chlorine remains an important reagent in fine chemical synthesis, helping to introduce chlorine atoms into molecules in controlled ways to alter their reactivity, stability, or biological activity. Biologically, chlorine in the form of chloride ions is essential for human health. Chloride helps regulate fluid balance, blood pressure, and pH in the body. It is a major component of extracellular fluid and is necessary for the production of hydrochloric acid, HCl, in the stomach, which aids in digestion and prevents microbial infections. The body obtains chloride primarily from dietary salt, and deficiencies, while rare, can lead to metabolic alkalosis and other issues. Chlorine also plays a role in atmospheric chemistry. Although not abundant in the upper atmosphere, certain man-made chlorine-containing compounds, especially chlorofluorocarbons, CFCs, have had a significant environmental impact. Once released, these compounds eventually reach the stratosphere, where ultraviolet radiation breaks them down, releasing chlorine atoms. These atoms catalyze the destruction of ozone molecules, contributing to the thinning of the ozone layer. International agreements like the Montreal Protocol have successfully reduced the production and use of CFCs, leading to gradual ozone layer recovery. Chlorine has several isotopes, but only one stable isotope, chlorine-35, which makes up about 75% of natural chlorine, and chlorine-37, which accounts for the remaining 25%. These isotopes are useful in nuclear magnetic resonance, NMR, and other analytical techniques. Radioisotopes of chlorine, such as chlorine-36, are used in hydrology and geological dating to study groundwater movement and determine the age of ice cores and rock formations. Chlorine gas, while industrially valuable, is hazardous to humans and must be handled with great care. It is highly toxic when inhaled, causing damage to the respiratory system and mucous membranes. Historically, chlorine gas was infamously used as a chemical weapon during World War I, making it the first large-scale use of poison gas in warfare. Today, its transport and use are strictly regulated, with safety protocols in place to protect workers and the environment. Despite its risks, chlorine's versatility makes it indispensable in both traditional and emerging technologies. For instance, in energy applications, chlorine is used in the production of high-purity silicon for solar panels and semiconductors. In battery technology, chlorine-based compounds are being investigated for next-generation energy storage systems. In the pharmaceutical industry, many drugs contain chlorine atoms because they enhance drug stability, potency, or solubility. Chlorine also plays a role in food safety and preservation. It is used in the sanitation of food processing equipment and in washing produce to reduce microbial contamination. While its use is generally considered safe and effective, there is ongoing debate about potential byproducts and the importance of proper rinsing and dosage control. From an economic perspective, chlorine is produced mainly through the electrolysis of brine, a concentrated solution of sodium chloride. This process also yields hydrogen and sodium hydroxide, both valuable industrial chemicals. The global chlorine market is closely linked to trends in construction, healthcare, and manufacturing due to the extensive use of PVC and other chlorine-based products. Supply chain stability and environmental concerns continue to shape the production and use of chlorine worldwide. In summary, chlorine is a vital element with a wide range of applications across water treatment, chemical manufacturing, healthcare, and industry. While its reactive nature makes it potentially dangerous in certain contexts, it is also the source of its value, enabling the creation of materials and products that are integral to modern life. As technologies evolve and environmental concerns continue to grow, chlorine's use will likely be refined and optimized, ensuring it remains a critical component of industrial progress and public health.